There's a thing, there's a thing, and zoom. Come on. All right, first of all, Frank, are you okay? Okay. Round one, set notation. Honestly, I have no idea when the last time. Oh, God. How many of you had geometry during spring 2020?
I genuinely don't remember.
You did not have geometry last year. You did not do geometry, algebra 2 last school year. You had geometry the year before.
I think I had it.
Okay. The reason I asked that last semester, we found out things that my pre-calc classes, they were all in geometry. So I talk about a lot of stuff and they just said, "Huh?" Because they had never seen it. There's a lot of stuff with our geometry classes that they don't cover that I wish they would. But B, there's stuff they just plain didn't get to. And C, there's stuff that kids decided not to do. So that happened. I also found that with Algebra 2 last semester. In Algebra 2, we discovered that no one had ever done probability and statistics. Ever. Like, combination? Huh? Box and whisker plot? What? Okay, like, had never seen it. So, there was some surprises last semester and we had to cover some stuff. The reason I'm talking about that is set notation should have come up in geometry. It should have first been introduced middle school and honestly, algebra half. I actually did this last semester with my algebra half. I don't know when the last time was you saw this. So as we're getting into chapter 1, where we're talking about the domain and range of functions, where we're analyzing them in depth, you gotta make sure that you know what the crap their symbols mean. So we'll start there. Set. Any collection of objects. A set can be big, it can be small, it can have other sets within it, and it's those cute little squiggle brackets. Some of you have really bad handwriting, so those squiggle brackets might be tough. As long as it's not a line and it's not a 3, we're good. Okay, squiggle brackets. And you use a letter to define the name of the set, and then you put a bunch of junk in it. There's infinite and finite series and sequences. There's a set that ends finite. There's a set with an ellipsis at the end that is infinite, goes forever. And then we have element of. You ever seen that symbol? Or maybe it's been a while since you've seen it. Element of, it's a kind of a curved E. And it means this is an element of that set. So if the set is the kids in pre-calc right now, then I would say Brooke is an element of set pre-calc. Okay? Not to be confused with subset of. So that would be like that means subset. So it's basically this symbol without the middle. You have element of, subset of. Element of means it's a single thing in the set. Subset means it's a set contained within that set. This would be everyone who's wearing jeans is a set. Kids wearing jeans that are in pre-calc is a subset of pre-calc. Okay, what I'm saying? Like a smaller group within the group. Kind of like those, the Russian nesting dolls. I remember the beginning of Toy Story, the little bulldog thing that opens up and the guy comes out and opens up and the guy comes out, opens up and the guy comes out. Okay, subsets. So set notation is just, here's my set, here's the thing. So we start off with basic. Can you write what a set is? And can you tell me true or false about the set statement? So if I say n is a set of whole numbers greater than 12, less than 16, I'm going to name n is whole numbers. Whole numbers are fingers and toes, Alabama math, plus 0. Okay? So what are whole numbers greater than 12 and less than 16? Okay, you kind of pause and wait. Did I maybe kind of? Because you didn't say 12 or 16. Why not? Okay. Are you taller than yourself? No. 12 is not greater than 12, right? So 13, 14, 15, close squiggle brackets, and then they ask, is 15 an element of n? No, is it? Yeah. So true. Okay, what I'd like you to do is those three. People always argue about B, vowels. We're going to use Wheel of Fortune rules. Y is a consonant. Remember, Y can be a vowel or a consonant. It should. The set of vowels should look like. I'll just do the one. The set of vowels should look like someone just got kicked in the nethers. Ow! A-E-I-O-U. Okay. So there's my set of vowels. That I swear that's an E. And then you tell me, is G an element of V? And then do the other ones. Okay. If you have not been here before, we are set up like a Senate chamber for a reason. I want you talking to each other. If it's during your daily quiz at the beginning class, no, I want you to do it. I don't want you and your neighbor to do it. If it's during a test, I want you to do it, not you and your neighbor to do it. For everything else, I want you talking. I want you arguing about it. I want you conversing. I want you talking to the people next to you. I want you shouting at the kid across the room. Well, not shouting at them, but dialogue. Okay? So, finish off BCD and argue with your neighbors. Did you do it right? Do you got the same thing? Why did you put this and they didn't? It should not be a dead silent library in here. I never did attendance because ADHD go burr. All right. Is there a Jack? Huh. Okay. Is there an Ava? Okay. Okay. Kai? Okay. Mariah? Did we have Mariah? She's out. Okay. Q? Q? Quentin? Gone too? Okay. Maddie? Max? You have older siblings. Name? The name sounds familiar, but that name doesn't sound familiar. Okay, we got Emma, Jaden. You're OG. You are now OG. Okay. Anna, Kira. We have a no Kira. Okay. We have Caden, Isaiah, Beta, Callie. That's right, we had two Callies. God. Why do we have so many doubles in here? We got a Callie and a Callie. We got a Jaden and a Jaden. We got a Caden and a Caden. All right. Carter. Reagan. No Reagan. Okay. Eli. There. Brooks here. OG's here. Finn's here. Matt's here. Kylie. Yeah. And okay. So the other Callie. So we got Callie and we got Callie. Callie and Callie. Aslan. Aslan. The lion. Lion, Witch, and the Wardrobe. You were there in the ancient times. That,
said I was like General Custard.
considering he was a horrible human being and a really bad general, that's not good. Like, you read into the history of it, like, he really was a terrible, terrible person. He was a drunk. He ignored all the advice of his lieutenants. Like, Custer was a horrible, bad person. Tell them that you do not appreciate that. All right. So the set of all vowels, obviously G is not a vowel because then instead of oh, it would be ah, and that doesn't make sense. You get kicked and you kind of in the middle. M is the set of all months beginning with J. What do we got? So January, June, July, April, clearly not that. Make sure that you're labeling them like this. And X is a set of all numbers. Ooh, I really hate that statement. X is a set of all numbers on a die. Okay, if you're a dork, you know why I hate that. They are referring to a normal D6. What happens when we have a D4? Whoa. D4, D10, D20, D8.
I mean, don't they all contain 4?
Okay. What happens when you have, I used to have a D100. It was like a golf ball with all the numbers written in the divots. And then it was like the ball itself, and then there is water casing around it. And so, like that's how an 8-ball works. It's got a little D20 in there, and then it floats up to the top. Well, the little air bubble at the top of it would show you which number was at the top. But there's a lot more than 6 sides on a die. Technically a coin is a D2. Okay. So when they say X is a set of all numbers on a die, usually books, because they're written by college professors who have no imagination, mean a D6. So I would list 1, 2, 3, 4, 5, 6. 4 is one of those numbers. Okay.
The only time I really joke about it was 7. It's on some, not all.
That is very true. So that's set notation. Within them, we have things like a universal set is a set of everything. All objects possible. Did you need to stop me about a thing? There was a hand up. Name, rank, and serial number. In the back. The one not looking at me. Everyone else is looking at you, but what is your name?
Me?
Yes.
Isaiah?
Isaiah, hi.
Hi.
You were doing kind of this. I don't know if that was a question or if you were just stretching awkwardly. Okay. I want to make sure that if I go too fast over a thing, if I have the reflexes of a cat whose head has been hit too much. So If you see me starting to pick up an eraser, it's already too late. You need to speak up. Okay? All right. So, set of all objects possible. That would be like the universal set is people in this room. A is the set of PreCalc students in this room. B is a set of PreCalc students in this room with glasses. You get what I'm saying? Where A, yeah, that's all of you, but then you got me hanging out here. Okay? I'm still a part of the universal set because I am in this collection of objects, but I'm not a part of the PreCalc group. Okay? So universal set, subset, we already said, is a smaller collection within the collection. Okay? A collection within a collection within a collection, right? I don't know. Write it however you want. Complement. You notice that that one's got an E in there. There's a big difference between a complement and a complement. Complement. Oh, the shoes are cute. Complement is the opposite of or the pair with. In the case of sets, complement is not this. So if I say, I can write it as not B, or I can write it as B prime. Those both mean everything that's not in B. So that would be all the stuff in A that isn't in B. It would also include me hanging out there on the edge in the universal set. Okay? Let's test your old school knowledge there. Why does Sullivan hate that one? Why do I not like this to mean the complement of B? Why might that be confusing? Okay, if your handwriting's a little off, it might look like B to the first. If I have a double prime, it might look like B to the 11th. Where have we seen that notation before? Speaking of geometry. Y'all remember? Triangle ABC prime? Meaning I have translated it, I have dilated it, I have rotated it, I have done something with my original triangle, and now the next iteration of it is called ABC prime. And then I do something else, and now it's ABC double prime. And then I do something again, and now it's ABC triple prime, and on and on and on. So we've seen that notation somewhere else. It gets used in transformations and geometry. It also gets used when you get to calculus to mean derivative. So I really don't like that. And the book doesn't show this notation at all. But this specifically means complement of B. This means not B. And they refer to the same space. So there's a lot of textbooks or mathematicians that will prefer to use not B in place of complement of B. I want you to know that they mean the same thing, or they're talking about the same thing. Okay? Element of versus contained in. We don't have the contained in this book, so don't worry about that. Element of, how about subset of? Okay. So again, just making sure we are careful with those symbols, that we know what they mean. So down at the bottom, they give you, U is your universal set. It's the set of all digits. Remember, there's 10 of them. 0 counts, not just 1 through 9, also 0. So I have 10 digits, and then A, B, C, D, and E are all subsets of that universal set. I'd like you to answer those two questions. How do I read that? What does it mean? And then, is it true? If it's not true, tell me who's the holdup. Which element is making that not true? Okay. Check with your neighbors. Argue with folks. Make sure you're on the same page. Okay, what does that goofy little symbol mean again? Subset of. So if I say state whether B is a subset of A is true, does all of B fit in A? Yes. The 5 and the 7 from B are both in A, so true. Is E a subset of D? Does 6, 3 fit in 2, 3? No, because 6 is not in there. Okay? The 2 has nothing to do with it. It's does the 6 and the 3 belong in D? And no. So I would say false. Okay, is that right? True for this, I'd say false. I'd say 6 is not an element of D, is how I would write that. 6 is not an element of D. Okay, so just going back through some old stuff that, again, if you haven't seen set notation since chapter 3 of algebra, then, well, maybe it's been a while. Okay. Womp. Okay, union, intersection, and empty set. We have been using something like union for a long time. So that's union. And it's very similar to OR. Okay, union specifically is with sets. OR is like an inverted caret. It means, well, here or here. I use OR and symbols an awful lot just because I'm lazy. And I don't want to write out the word OR. You know, that extra 3 motions might give me carpal tunnel again. Colors. Okay, union. Union is the OR of the math world of sets. If I asked for example, A union C, that means everything that's in A or C. Think I want to go to the basketball game tomorrow night, so mom says I have to wash the dishes or clean my room. If I do either one of those, I get to go, right? So anything that meets either one of these conditions works. That's going to be all of A or C, all of it. Okay? So I would list that out as a set. That's 1, 2, 4, 5, 6, 7. If, on the other hand, I have intersection, it's the and of the math world. Well, now, if I say A intersect C, it's got to be in A, but it's got to be in C. I look for that overlap, everything in the middle. Okay? You want to go to the basketball game? Mom says, cool, you got to wash the dishes and clean your room. Those are the only two ways that this happens. Because if I pick 1, 2, or 7, they might be in A, they might be in C, but they're not in both. Okay. Empty set. We have been using that symbol for an awful long time. That. We've been using empty set to mean no solution, maybe. Or there's no answer, there's no solution. We use that because technically when I solve an equation, well, he picked a number I don't automatically know off the top of my head. Come on. Okay. So we would always leave it like that, but technically, x is the set of all x's such that x is negative 14, where x is an element of the reals. Technically, that's everything that was there. You saw set builder notation back in Algebra Half. I can bust open one of those books and show you. Now, whether you remember it from the ancient times or not, okay. Another way you may have seen it instead was just list the set of solutions. Okay. So what happens if there is no solution? Well, those squiggle brackets are the set. If there's no solution, then nothing goes in the set. And it would look really weird if right? Distribute, subtract 3x from both sides. Negative 5 does not equal 18. It would look really weird if I said that's my solution and just didn't put anything in there. So they make up a symbol to say the set is empty. Now what you don't want to do is this. You put set brackets around the symbol that means empty set. That means the set of the empty set. It's like saying Mr. Sir. It's kind of redundant. Okay? So empty set is its own symbol to mean there is nothing that meets this condition. So, U is the universal set. R, S, and T are your subsets. I'm going to ask you to do two things here. One, answer those questions. But two, I want to see, can you make the Venn diagram? Can you make universal set box, R, S, and T are somehow floating around in there. Can you figure that out, what that looks like visually? Okay, I know that you use Venn diagrams more in probably your English and history classes as a organizer. Probably less in math up until now. Can you show me what that looks like? You have to be able to answer A, B, and C. But can you show me what that looks like visually? Argue with your neighbors. Okay. We ain't doing it right unless someone's yelling at their neighbor like Han yelling at Chewie. No, that one goes here, this one goes there. I mean, Venn was obsessed with circles. If you want to get freaky on it and put triangles, you go right ahead. You do you. That's really thinking outside the circle. That kind of what if question is indicative of a mono blue personality. I don't really want to see what people come up with. Like psychologists will do this with little kids. They'll just give them a random prompt and see what they draw, and start interpreting it and try to analyze their life. It's great.
Like grasping at straws.
Yeah. Any of you ever done the Rorschach tests? The ink blots?
No.
What do you see? I see my mother judging me. Never need to ask, just go. No. As the song says, you're a big kid now. Brooke over here making Triforce signs. That's great. There is no one correct way to do this. I just want to see what you come up with. See, if you got a Venn diagram that is literally just two circles, that's not a big deal. As soon as you start throwing multiple sets and a universal set with it, starts getting funky. Maybe I feel like that. What? Okay, no. T is a single element, right? So start with, is that single element in any other set besides the universal? No. So that means T is out floating out here. This is Vanellope with her code almost deleted. Just okay. Then look at R and S. Look at their overlap. I see a 4 and a 6. And then this guy's got a 2. That guy's got a 5 and a 7. And then I look for what has not yet been done. 3 and an 8 are just out floating in the ether here, still a part of the a universal set. Now, I did mine like, I don't know, Picasso, just random shapes. That was one way that I did it. That's not to say that I can't have R, S, and T as a traditional circle Venn diagram. I just have to be careful, how do I set it up so that I meet the correct conditions? So T has 1, and that 1 is not in the others. In T, but not in the others. R and S have a 4 and a 6 in common, so I have to make sure it's in the R and the S, but not in the T. 4 and 6. R has a 2, that doesn't belong to anything else. S has a 5 and a 7, that doesn't belong to anything else. 3 and 8 are again floating out in the ether. Okay? I could do this with any shape. Most people will use circles just because they're nice, having a symmetrical shape, having something that's easy to define, universally acknowledged boundary. Okay, so then, what does this say? R union S, which means anything in R or S. So that's 2, 4, 5, 6, 7. R intersect S is that 4, 6. T intersect S has nothing, so I put empty set. Okay? Again, don't put the brackets around empty set. That's the empty set of empty set. Okay? That's Mr. Sir. Hey, dude man. Okay? Y'all good? Okay. I don't really have the thumbs pages too much in our notes in chapter 0. The thumbs pages, like every now and then as I go through the notes, you'll see a page that's got just extra examples ready for us if we need them. And then a little thumb in the corner to remind me, okay, this is where we double check. Does everyone follow along? Does everyone know what's going on? Thumbs up. I get it. I'm confident. I'm good. We're great. Sideways, I'm a little sketchy. I want to do number 15 because it's 15 sus, right? And then I have no freaking clue what's going on. So normally I'll just, in the middle of a lesson, like, tell me how we're doing, and everyone just kind of doing those, because a visual check like that is a lot faster for me. Not everyone is comfortable speaking up. And you know what? Sometimes if you're hesitant on this, you just kind of do one of these. You know, it's less obtrusive. Not everyone is confident enough to say, or secure enough to say, I don't get this. Some kids are, some kids aren't. Just, I like doing that instead. I said we're going to go 0, 1, 0, 2. 0, 1's really fast, just set notation. 0, 2 is, hey, y'all remember complex numbers. Okay, back in Algebra 2, we very first learned what an imaginary number was. You're like, wait, I got problems with the real ones. Why are we doing imaginary now? Okay, imaginary numbers are an idea. It's literally imaginary. You cannot graph it unless you relabel a coordinate plane or a 3D space with an imaginary axis. Say, this is not real, but I'm going to pretend it is. You can't actually touch this. You can't put this on a number line. You can't see it in a physical space unless defining it that way. But what it does is it allows us to unlock other math. Like, how many times have you been stuck in a game and you just cannot progress until you get past this spot? Like, I got to find the thing. If I don't find the thing, I can't go anywhere. Link is just going to wander around this corner of the map for the rest of eternity because he can't find that bracelet. Okay? Imaginary numbers were the thing that unlocked that unlocks the rest of math, because it's an idea and a placeholder that allows me to start working with quadratics and cubics and quartics and composing and decomposing them in ways I wouldn't have been able to before. It unlocks the rest of math. I is square root of negative 1. Okay? I is a square root of negative 1. Square root means what times this thing makes negative 1. Well, what's 1 times 1? Negative 1 times negative 1. Also 1. Okay, the only way to get a negative is to multiply by a negative, an odd number of negatives. So if I have a even index, a square root, how can I take an even number of negatives to make a negative? It's not possible, right? So we put I as a placeholder for that. Now, if I take that square root of negative 1 and square it, we all know that inverse operations, square and square root, cancel each other out. That's why I squared is a negative 1. I to the third. Well, if I know that I squared is negative 1, and this is the square root of negative 1, that's negative square root of negative 1, so I call it negative I. I to the fourth can be broken up into I squared and I squared. Negative 1 by negative 1 is now positive 1. Okay, I know that I go off about what the ring of I is in Algebra 2. I don't know if you've all seen it. What happens when I keep going? If I go past I to the fourth, well, since I to the fourth is just 1, then I to the fifth is 1 times I. I to the sixth is 1 times I squared, is 1 times I to the third, is 1 times I to the fourth. And you see they're the exact same things. And you get your very first ring. Not talking like, oh, he gave me his class ring, we're going to be together forever, and break up 4 months later. I'm talking about I squared, I cubed, I to the fourth being I, negative 1, negative I, 1, and it keeps repeating itself forever. Kitten calendar, kitten calendar, kitten calendar, kitten calendar. It's going to keep repeating itself forever. And this goes in any terms of the exponents. So say, for example, I had I to the 23rd. Well, we know that I to the 5th is just I to the 4th times I. This is 23 spaces around the ring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I to the 23rd is -1, or negative I. There we go. Now there's an easier way to do that instead of counting all the way around there, because I'm about to throw an I to the -305th at you. What I do is I break that up. If I to the 4th is 1, what is a multiple of 4 right under 23? 20. So I'll call this I to the 20th times I to the 3rd. Well, this is I to the 4th to the 5th, right? I multiply exponent raised to an exponent. So if I to the 20th is I to the 4th to the 5th, then this is 1 to the 5th, then this is just 1. What I do is break it into an exponent that's a multiple of 4 and an exponent that's not a multiple of 4. Alakazam, I to the 23rd is I to the 3rd, or -I. So imagine that as a bigger number. Imagine I to the 337th. What's a multiple of 4? Right below 337. 336. Remember, every time you hit 100, since 100 is divisible by 4, it's just the last two digits that matter, right? 300 divided by 4 is always going to happen evenly. So you look at the 37, okay. So this is I to the 336 times I to the 1st. This is I to the 4th, and it happens, well, 336 divided by 4 is 25, 25, 25, 9, or 85. No. And that's just 1. So I to the 337th is just I. Okay? It's a structure known as a ring. A ring is something that will continue to repeat itself forever. In either direction, positive or negative. This is, this is the dragon eating its own tail. This is yin and yang. This is, this is the movie where the guy tries to run out of the room and then they'd come in from the other side of the screen, like they're going crazy. Okay, yeah.
Okay, so every odd number is going to be an I or a negative I? Is
Yes.
there an easier way to like, decide between if it's I or negative?
1 or 3 past it. I mean, yeah. It's which of those 4 is it equivalent to? Get rid of all of the iterations of 1. What is left? Now, you could just do that in mental math, right? The 300 doesn't matter. 1 more than 36. I to the 1st. No? I to the 300 plus 36 plus 1. 1, 1, I to the 1st. Any multiple of 4 is going to be equal to, any I to the multiple of 4 is going to be 1. It's just you get rid of all the others. Then what if I were to throw a I to the negative? Y'all remember what negative exponents do?
Makes it smaller.
1 over. It's reciprocal. Okay? Think of it like you flip the light switch. Numerator or denominator. Well, you flip the light switch, numerator or denominator, upstairs or downstairs. Your 2 negative go downstairs. How many times have you been in a bad mood and your parents are like, go to your room? But as soon as you're in your room, you feel better, and you're just like, great, I'm away from you people, right? That's 1 over I to the 17th. Can't wait for my kids to be teenagers. Okay? Well, the problem with that is, well, yeah, this is I to the, right? 4 by 4 is 16. So that's 1 over I. Does anyone remember why this is still not finished?
Because I can't be on the bottom.
Why not?
It's a square root.
Because it's a square root. It is improper to leave a radical on a denominator. You have to rationalize it. This is 1 over the square root of negative 1. No radicals downstairs. It's like that first boy-girl party. No radicals downstairs. They stir up the girls, give them bad ideas. You need to bring him upstairs where you keep an eye on him. Get it? Eye on him? No? Okay. Squared negative 1 times squared negative 1, or I times I, is I squared. 1 times the square root of negative 1 is I. What is I squared? Negative 1. So that's I over negative 1, so I'll just call it negative I. That was a lot of work, right? And I'm going to show you something that takes about 2 seconds. Remember, exponents have their own laws. What happens when I multiply 2 exponents of the same base? I add them together. Any I to the multiple of 4 is 1. Anything times 1 is itself. Cheat code. What is a multiple of 4 really close to 17? Will that get me out of the negative zone? No, that'll put me at I to the negative first. Go one more. I to the 20th. Can we all agree that I to the 20th is 1? Like I to the 4th to the 5th, 1 to the 5th. It's just 1. Anything times 1 is itself. I haven't changed its value, just gave it a little 90s makeover, so now it can go to prom. Add the exponents. And wasn't I to the 3rd negative I? Splash zone. Okay. I can get around that negative thing and having a radical on a denominator and having to rationalize it by just using my properties of exponents. I don't need to do all blue stuff. Instead, I can take I to the negative 337th. Now, I don't want to do 336, right? Because it'll still be negative. 340 times I to the 340. This is just 1. Anything times 1 is itself. But if I smack those two together, I get I to the 3rd, which I know is negative I. Okay? Go further in math. Or I'll tell you what, if you're in PreCalc, you should just be in our math club or knowledgeable or both, and you should go to the math circle at BH. Okay? Go talk to like Dr. Nog and have him give you the rundown on rings and abelian groups and just make your brain explode. But they bring it down to like high school so I can still understand it. And then you come in here and throw proofs on the board and scare my freshmen. It's great. Those two? Show me. What are they? What are they equivalent to? So, what's a multiple of 4? Really close to 53. So I turn this into I to the 52nd times I to the 1st. And I to the 52nd is just 1. So it's just I. That's it. Now that's one way, is to rewrite it as its equivalent. The other way is, if I have I to the 53rd, how about I take it times I to the negative 52nd? Instead of rewriting it, well, I multiply it by an exponent, I add the exponents. 53 plus a negative 52 is 1. Okay, so that's one way to do it. This, I'm guessing I to the 18th equals 1 over I to the 16th times I squared is 1 over 1 times negative 1 is 1 over negative 1 is negative 1. I'm guessing we don't want to do that. When instead I could just say times I to the 20th, turning it into I squared, turning it into negative 1. Okay? So you learned what imaginary numbers were. You threw them on answers. You may have worked with them as you were creating polynomials, but maybe didn't go into depth on what it really means and what you can do with it. Okay? Complex numbers. Anything that's got a real and imaginary component is considered complex. Okay? It'd be like if I talk to name, rank, and serial number. Caden? Oh yeah, Caden, Beta, gotcha. Okay. So, if I ask Caden, who's your best friends? And he said, it's kind of complex. That might be because Caden has real friends and imaginary friends. Okay? His real friend, 5, and his imaginary friend, 2i, together makes the complex number 5 plus 2i. I don't know why I got a random dot up there. Okay? Who are your friends? It's complex. Okay? Real parts, imaginary parts. A pure imaginary number is a number that is only imaginary component, no real components. Okay? That'd be like if I ask Callie who her friends are, and she's like, they're all imaginary. Let me introduce you to Toothy. Okay? Then, in that case, that's a pure imaginary number because it has no real component. A only real number would be just the 5. So if a complex number is something with a real and imaginary component, can you tell me how would you write negative 2 as a complex number? How would you write 6i as a complex number without changing their value? How do I turn negative 2 into a complex number with a real and imaginary component without changing its value? Well, now I've changed its value. I made my real friend an imaginary friend. You killed your friend and then you just pretended to talk to her ghost forever. Okay? There it is. I can add something onto it that's not worth anything. 0i. I can add something onto it that's not worth anything. Now they are complex numbers. This is why back in Algebra 2, when you're solving polynomials, it would say find all complex zeros. Find all complex roots. By saying complex, it's the umbrella term that covers all of my real and imaginary answers. Because my real numbers can be written as complex numbers. My imaginary numbers can be written as complex numbers. Okay? Now, that I, until we start using it as a square root of -1, that I can be treated an awful lot like a variable. Which means I can start to do operations with it. I can add and subtract them, pretty simple. I take the real parts together and the imaginary parts together. Okay? Veterans of my Algebra 2 will remember the phrase, keep your real friends separate from your imaginary friends, or else you won't have real friends, right? 5 plus a -2, -3i plus 4i. Put your real friends with your real friends and your imaginary friends with your imaginary friends. Right, Caden?
Oh, yeah.
Okay. Same thing goes for distribution. 14, -8i, -21i, and +12i squared. Okay? Now, where this gets hairy is when I combine like terms, what can I still do to it? Okay, that I squared is a -1. -1 times 12 is now a -12. So this is actually 2 minus 29i. That's the only catch. Now that I know about the ring of i's, if I ever get an I to an exponent, I can simplify it. Beyond that, it's just, algebra half combining like terms, multiplying binomials. I'm curious. I know we got sophomores in here now, and some kids love it, some kids hate it. Box method of multiplication. Some kids love it. They live and die by this. Other kids, Punnett squares, no, when they melt. It depends. I want to make it clear that in here, unless the directions specifically state solve the system by Gauss-Jordan, unless the directions specifically state solve by factoring then completing the square. Unless the directions are specific, you solve it however you're going to solve it. You do the work however you're going to do the work. I know that some teachers, some in this building, are adamant that if you do not solve it my way, if you do not do it my way, you're wrong. No. Okay, in the words of Damon Wayans, homie, don't play that. Okay? So if you want to do box method, if you want to do old school stack multiplication, however you're going to do it, I don't care. Those two, please. Talk it out with neighbors, watch your signs. Be careful with when it becomes I squared or not. Who is the kid? Who is the one in here? Yeah. Okay, top one. Who already goofed the second term? Because we missed that negative. Okay. What I would recommend whenever you see subtract a thing, regardless of what it is, like you're back in algebra half, throw that -1 there, and distribute. If you need to go all the way old school and chop up everywhere you see a plus or a minus so that you can identify the individual terms, do it. Okay? On this one, I distributed, and you're going to find that I really like writing mine like this as I distribute. Why would that be beneficial? You see the like terms, right? If I stack my like terms as I'm multiplying, as I'm writing, if I keep my like terms in a column, then I know those are the ones that go together. It makes simplifying a lot easier. So I know that these two will cancel out. I squared is a -1, so that's actually plus, and almost the meaning of life, 41. Okay. We'll do the polynomial thing later. Okay. Does anyone remember what these are called? Those. That's how I factor it. If I ever have a difference of squares, it factors into a plus-minus pair like this, yes. What were those plus-minus pairs called? Starts with a C. Conjugates. Okay. A conjugate is the exact same binomial, but you change the sign in the middle. And they're important because they allow us to do exactly this. They allow me to remove a middle term and square both terms. And what happens when I take a binomial times its conjugate, if I can use this idea that my middle term disappears and I end up with squares, I can use that to eliminate radicals. I can use that to eliminate square roots. And I is a square root. That means I can use this to simplify division problems. If I have 5 minus 3i over 1 minus 2i, well, no radicals downstairs. Stir up the girls, give them bad ideas. There's a lot of kids who are going to see this and they're going to be like, all right, I got this. Bam. Going away. But when I do that, now I end up with a 2i plus 4. Oh. Again, to the denominator and all that. But then I have a 2i plus 4 on the denominator. And you say like, all right, I got this. 2i. Yeah. And now you have 8i minus 4. All right, I got this. I'm going to do, and then you're just like a Yorkie chasing your tail, right? You're not going to go anywhere. So what I do is instead of all of that, I use that conjugate. I use the conjugate because the conjugate is going to get rid of the middle term that has a I, and then I'll have a 2i times a 2i. That's an I squared. I squared is a real number. So 5 by 1, 5 by 2i, negative 3i by 1, negative 3i by 2i, over 1 by 1, 1 by 2i, negative 2i by 1, negative 2i by 2i. Disturbert. Okay. And then I know that I squared is negative 1, so this is now plus 6. I know that I squared is negative 1, so this is now plus 4. And I know that these two will cancel. Okay? Because those two will cancel, because this term becomes real, I now have 5 plus 6, 10i minus 3i, 1 plus 4. Okay? Year after year after year. I have a kid take Algebra 2 or PreCalc with me, and then they go and do the dual credit college algebra. 1, if you get out of PreCalc with anything C or above, don't do dual credit college algebra. It's a waste of your time and money. You will just test out of it. Okay? It really is. The only case that I can see for someone going from PreCalc to college algebra is if you know specifically the college you're going to will not allow for a transfer of credit or for a test in. I actually have one of my seniors right now did pre-calc with me last year. She had to do college algebra first semester because the college she's going to would not accept a test in. It's a private school or a Christian school or something like that. Okay, so, but for everyone else, don't do that. It's waste of time and money to take college algebra after this. But I see every year a kid who has been in my class and they go and take college algebra. College algebra is online. You input your answers online. And they will come in my room just madder than mad, grab their laptop and like slam it on my desk and say, why is that wrong? I did it right. I got the work right there. I can prove it. I can put it back in. I can do, and they'll just, but it says it's wrong. Y'all know when you put stuff in an online test, the instructor writes what the correct answer is, and the computer just checks that you put what they wrote. And the correct, proper way to do this is to separate your real friends from your imaginary friends. I don't care. I really don't. If you give me red, I will take it. I want to stress and get you in the habit of putting the white answer instead because I don't want you to go on to some crotchety old math professor's class and they count your stuff wrong because you didn't do it their way. Why is the white one considered proper compared to the red one? Why is being separated right? Getting warmer.
Because they're both being divided by 5.
I have a real part and an imaginary part. They're complex numbers. That's the form of a complex number. A plus bi, real part plus imaginary part, is how you write complex numbers. Just like we write our fractions as improper fractions instead of mixed numbers. Because mixed numbers, you just have to turn to improper fractions to work with anyway. Okay? So I don't care But you are going to run across a math professor at some point that cares, and they're going to be a stickler about it. So, those three. Yesterday we talked about most people coming into pre-calc have probably been straight A's, maybe a handful of B's over the course of your career. You're used to things coming relatively easy. If you have to put in effort every now and then, it freaks you out because you have unhealthy expectations of perfection and put that pressure on yourself to always do everything perfectly. I don't care if you can do it in your head. Please write something. Everyone, I don't care how smart you are, until you hit an IQ of like 160 plus when the tests are no longer reliable, everyone is going to run into a point where you cannot do this in your head. Get in the habit of writing it out now. Because you do not want to be 21 years old in your abstract algebra course before you finally have to learn how to study and write things. It sucks. Anyone who was in my Algebra 2, you can also attest that you've gotten a bunch of quizzes and tests back that have a -1 somewhere at the beginning of the problem, a little domino next to it, and that's it. The entire problem was wrong. You screwed up. Nothing on there is right. But you did the process right and you have the work to back it up. If you don't have the work to back it up, I can't give you the partial credit. You try doing it in your head and you have nothing to back it up. Sorry, -5 out of 5. I want you to show your work because we're all more accurate and I can give you partial credit when you show your work. You have one of the coolest calculators in the building. Why are you using that? It's like I have an Escalade at home, but I'm going to drive my 92 Geo Metro. Casios are inherently superior to TIs. It's just TI owns the educational market, so that's what we use in class. This is half the price of those, and it does more stuff and does it better. TI 84s, usually you'll find them in the 120, 130 area. Unless, I didn't talk about that yesterday. Who in here has your own graphing calculator? Okay. Yay for you. Privilege is great. We don't need it. If you ever need a graphing calculator, I've got the bumblebees over there in class, and you all have a TI-83, the Ancient Magic, on your laptop. Y'all know where it is? I hope. Windows, all the way down to T's, TI-83 plus Flash Debugger. You got to go through this old school Windows 93 looking program. Oh, it went up there. Cool. And then you have to hit new, and then you choose your calculator, and then you have to hit play, and then it brings up your calculator. Okay, it is literally the same calculator that you will see. It's the one in Jaden's hand. It's just an emulator. I'm not a fan of them because you can hardly read the buttons, but it is something that everyone has access to. Narf. I am doing all of these wrong. I am doing all of these wrong. No, I'm not even going to go on to the other one. Okay. I did both of these wrong. Spot the error.
You didn't multiply the bottom on 8.
Okay. Common error. Kids will multiply by the conjugate and think that the denominator just disappears. It does not. Okay. Over 9 minus 12i plus 12i minus 16i squared. Those cancel. I squared is negative 1, so that's 9 plus 16 is 25. Again, separate your real friends from your imaginary friends. Otherwise, you won't have any real friends. Okay. Where'd I go wrong on B?
You multiplied by the complex instead of negating 6i.
Okay. I don't need a 0 because zeros times things are still zeros. Okay. Where am I still wrong? It's not wrong to have that 0 as a complex number. It's just overkill. Okay. If I separate my real friends from my imaginary friends, that's negative 1/6 minus 2/3 I. I can simplify it further. Yo, no radicals downstairs. They stir up the girls, give them bad ideas. He is a problem. He is a radical. 6 is okay. I know his dad. Now, how I got there wasn't wrong. It was just overkill. You went deer hunting with a bazooka. Okay? I don't need that. This is just 4i minus I squared over 6i squared. Well, that's -1 plus 4i over -6, reducing. I don't need to multiply by the 6 because the 6 isn't the problem. The I is the problem. Okay? And then the bell's going to go ding, so I can't get to C. But that is the end of it, right? Flip it, and now it's 0, 3. Perfect. Okay? Your assignment, in terms of number, is a little bit bigger than usual. It's like 11 or 12 problems, but they're all smaller ones like this. Okay? So again, it should be in that 15, 20-minute range. If you're going 30 plus, distraction-free, you got to talk to me. So plan book should be correct right now. Yeah, I never write it on the board because ADHD go burr. I'm going to forget every day.